The National Electrical Code, or NEC, does not specifically require a certain percentage of spare capacity in electrical panels, including for 42-pole panels. However, the NEC does provide the following general guidelines. NEC Section 408.11 requires that a sufficient number of spare spaces be provided in panel boards to permit the future installation of additional branch circuit to overcurrent devices without requiring the replacement of the panel board. NEC Section 408.3 states that the total amp rating of the overcurrent devices installed in a panel board shall not exceed the current rating of the panel board. While the NEC does not mandate a specific percentage of spare capacity, it is considered good practice by many electricians and industry organizations to provide some level of spare capacity in electrical panels. The International Electrical Safety Code, or S, and the National Electrical Contractors Association, or NEC, both recommend providing at least 20% spare capacity in electrical panels. This recommendation is based on the expectation that future electrical loads may increase, and it allows for the installation of additional circuits without overloading the panel. While the NEC does not explicitly require 20% spare capacity in 42-pole panels, it strongly encourages providing sufficient spare capacity for future electrical needs. Providing 20% spare capacity is a commonly accepted industry standard and best practice for electrical installations. When planning an electrical installation, considering future needs is crucial. Adequate spare capacity ensures the electrical system can handle increased loads without major modifications or replacements. Firstly, assess the current electrical demands of the building or system. This involves calculating the total amp requirements of all existing loads, including lighting, appliances, equipment, and other devices. Secondly, anticipate future electrical needs. Consider potential expansions, new equipment installations, or changes in occupancy that could increase electrical demand. Thirdly, consult relevant electrical codes and standards such as the NEC, S, and local regulations. These codes provide guidelines and requirements for electrical installations, including spare capacity. Fourthly, determine the appropriate level of spare capacity based on the assessment of current and future needs. A commonly recommended practice is to provide at least 20% spare capacity in electrical panels. Fifthly, select an electrical panel with sufficient spaces and amp rating to accommodate both current and future loads, including the desired spare capacity. Ensure that the panel is properly sized to handle the total amp load of all circuits. Sixthly, install the electrical panel according to manufacturer's instructions and relevant electrical codes. Ensure that all wiring connections are secure and properly insulated. Seventhly, label all circuits in the electrical panel clearly and accurately. This helps with troubleshooting and future modifications. Eighthly, document the electrical installation, including panel schedules, circuit diagrams, and load calculations. This documentation provides a valuable reference for future maintenance and upgrades. Ninthly, periodically inspect the electrical panel and system to ensure that it is operating safely and efficiently. Address any issues or concerns promptly to prevent potential problems. Tenthly, consider using energy-efficient lighting, appliances, and equipment to reduce overall electrical demand and conserve energy. By following these steps, you can ensure that electrical installations have adequate spare capacity to meet both current and future needs, while also adhering to relevant codes, standards, and best practices. Panel boards serve as distribution points for electrical power within a building or facility. They receive power from the main service entrance and distribute it to various branch circuits that supply lighting, receptacles, equipment, and other electrical loads. The design and installation of panel boards must comply with the NEC and other applicable standards to ensure safety and reliability. Panel boards are typically enclosed in metal cabinets or enclosures to protect against accidental contact with live electrical components. The enclosures are equipped with doors or covers that can be opened for access to the interior of the panel board. Panel boards are available in various sizes and configurations to accommodate different amp capacities and numbers of branch circuits. The amp rating of a panel board indicates the maximum amount of current that it can safely handle. Branch circuits are individual circuits that supply power to specific electrical loads, such as lighting fixtures, receptacles, or appliances. Each branch circuit is protected by an overcurrent device, such as a circuit breaker or fuse, which is designed to interrupt the flow of current in the event of an overload or short circuit. Circuit breakers are resettable overcurrent devices that can be tripped manually or automatically to protect the circuit. Fuses are non-resettable overcurrent devices that must be replaced after they have been blown. Panel boards are typically equipped with a main breaker or main switch that can be used to disconnect all power to the panel board. This allows for safe maintenance and repairs to be performed on the panel board and its associated circuits. Panel board schedules are used to document the circuits and loads connected to each breaker in the panel board. The schedule provides a quick reference for identifying circuits and their corresponding loads. Proper labeling of circuits and panel boards is essential for safety and convenience. Labels should be clear, accurate, and durable to ensure that they remain legible over time. Panel boards should be installed in accessible locations that are free from obstructions. This allows for easy access for maintenance and repairs. Panel boards should be properly grounded to provide a safe path for fault current in the event of a ground fault. Grounding helps to prevent electrical shock and equipment damage. Panel boards should be inspected periodically to ensure that they are in good condition and operating safely. Inspection should include checking for loose connections, damaged components, and other potential problems. Any issues or concerns should be addressed promptly to prevent potential hazards. When working on or near panel boards, it is essential to follow proper safety procedures to prevent electrical shock and other injuries. These procedures include wearing appropriate personal protective equipment, such as safety glasses and insulated gloves, and energizing circuits before working on them. Only qualified electricians should perform work on panel boards. Qualified electricians have the training, experience, and knowledge necessary to safely install, maintain, and repair panel boards. Electrical codes and standards are constantly evolving, so it is important to stay up to date with the latest requirements. This ensures that electrical installations are safe, reliable, and compliant with applicable regulations. The NEC provides detailed requirements for the installation and maintenance of electrical systems, including panel boards. Compliance with the NEC is essential for ensuring electrical safety and preventing electrical hazards. The ES provides guidelines for electrical safety in the workplace. Compliance with the ES helps to protect employees from electrical hazards. NEC provides resources and training for electrical contractors. NEC membership demonstrates a commitment to quality and professionalism in electrical contracting. Proper electrical design, installation, and maintenance are essential for ensuring the safety and reliability of electrical systems. By following best practices and complying with relevant codes and standards, you can minimize the risk of electrical hazards and protect people and property from harm. Regular maintenance of electrical panels is crucial for ensuring the safety and reliability of electrical systems. Neglecting maintenance can lead to various problems, including overheating, loose connections, and equipment failure. Firstly, schedule regular inspections. Periodic inspections of electrical panels should be conducted by qualified electricians to identify potential problems early on. The frequency of inspections depends on the age and condition of the panel, as well as the operating environment. Secondly, check for loose connections. Loose connections can cause overheating, voltage drops, and even electrical fires. Inspect all connections in the panel, including those at breakers, terminals, and busbars. Tighten any loose connections using the appropriate tools and torque specifications. Thirdly, look for signs of overheating. Overheating can damage insulation, wiring, and other components in the panel. Look for discolored or melted insulation, burnt wires, and other signs of excessive heat. If overheating is detected, investigate the cause and take corrective action immediately. Fourthly, clean the panel. Dust, dirt, and debris can accumulate in electrical panels, reducing their cooling efficiency and increasing the risk of arcing and short circuits. Clean the panel regularly using a vacuum cleaner or compressed air. Be careful not to disturb any wiring or components during cleaning. Fifthly, test circuit breakers. Circuit breakers are designed to protect circuits from overloads and short circuits. Test circuit breakers periodically to ensure that they are functioning properly. Use a circuit breaker tester to verify that breakers trip quickly and reliably when subjected to an overload condition. Sixthly, replace damaged components. Any damaged components in the panel, such as breakers, wiring, or insulation, should be replaced promptly. Use only approved replacement parts that are compatible with the panel. Seventhly, label circuits clearly. Clear and accurate labeling of circuits is essential for safety and convenience. Ensure that all circuits are properly labeled with their corresponding loads. Update labels as needed whenever circuits are added or changed. Eighthly, document maintenance activities. Keep a record of all maintenance activities performed on the electrical panel, including inspections, repairs, and replacements. This documentation provides a valuable reference for future maintenance and troubleshooting. Ninthly, train personnel. Ensure that personnel who work on or near electrical panels are properly trained in electrical safety and maintenance procedures. Training should cover topics such as lockout-tagout, personal protective equipment, and safe work practices. Tenthly, follow lockout-tagout procedures. Before performing any maintenance on an electrical panel, always follow lockout-tagout procedures to de-energize the circuit and prevent accidental energization. Lockout-tagout involves disconnecting the power supply to the panel and placing a lock and tag on the disconnect switch to prevent it from being turned on accidentally. By following these maintenance tips, you can help to ensure the safety and reliability of electrical panels and prevent costly repairs and downtime. Always consult with a qualified electrician for any electrical work that you're not comfortable performing yourself.